All right, so just like we've talked about proving triangles, similarity and congruent triangles, we're also going to be able to prove quadrilaterals using a coordinate plane. So let's quickly recap. Let's remind ourselves that there are several different types of quadrilaterals. You've learned 6 of them. So first of all, we can break our quadrilaterals down into whether or not there are 2 parallel lines, 2 sets of parallel lines, or no parallel lines at all. And so if we're looking at 2 parallel lines, we're looking at a trapezoid. It can either be just a regular trapezoid or a trapezoid where the legs are congruent, and we call that an isosceles trapezoid, which should indicate that the base angles are going to be congruent, just like when we talked about an isosceles triangle. Well, then we get a situation where we've got 2 sets of parallel lines, and now we're talking about a parallelogram. A parallelogram can be broken down into 3 more specific shapes. A rhombus, where you have 2 sets of parallel lines and they're all congruent. However, a rhombus does not make 90-degree angles. What it does do is the diagonals make 90-degree angles. You've got a rectangle. A rectangle has opposite sides that are congruent, and the diagonals are also congruent to each other. And then lastly, we have a square, and a square has all the characteristics of a parallelogram. 90-degree sides, even 90-degree angles, even sides, and the diagonals cross as well at a 90-degree angle. And then finally, if you have a shape that has no parallel sides at all, you're talking about a kite. A kite does have one bisected diagonal, and they cross at a 90-degree angle, and also the corresponding sides, the consecutive sides, are also congruent. Okay, so that's a review of all the quadrilaterals we've talked about so far. So what's the first thing, if we want to prove the shape that we're looking at is whatever shape it is? What is the first thing we're going to look for? Well, the first thing we're going to look for is whether or not they have parallel lines. And parallel lines have the same slope. And so remember, to find slope, you do rise over run, which is equal to y2 minus y1 over x2 minus x1. And if the slopes are exactly the same sign, same numbers, you're looking at parallel lines. Okay. Now the second thing we can look for is whether or not the sides are congruent, the sides of the shape. And so to do congruent sides, we're talking how long the sides are, their length, or we can think of distance. So we're going to have to use that distance formula we've been working on, which is the Pythagorean theorem is the easier way to do it. A squared plus b squared equals c squared. And if this is even on both of them, then you've got congruent sides. Third thing we can look at is our bisectors. If we're bisecting a line, that means we're cutting it in half. So we'll be looking for the midpoint formula. And as you all remember, the midpoint formula, you take your x coordinates, add them, divide by 2. You take your y coordinates, add them, and divide by 2. And then finally, we're going to look to see if there's 90-degree angles in either our sides or our diagonals. And to do this, we're testing to see that our shapes are perpendicular. And by perpendicular, remember, they should be opposite reciprocal slopes. And so how this looks is if you had negative 1/2 as your slope, opposite reciprocal to that would be positive 2. Remember that? If you had positive 3 as your slope, the opposite reciprocal would be negative 1/3. And let's say you had negative 2/3 as your slope, the opposite reciprocal would be 3/2. So we're going to be using all 4 of these formulas that we've been working on all year to test whether or not our shape is what it is. So the first thing, obviously, you're going to do is you're going to look at the shape. And you're going to see, does it look more like a parallelogram? Does it look more like a rectangle, a rhombus, a square, or a trapezoid, or a kite. And then this is a cheat sheet that you can use to help you kind of minimize the number of steps that you need to do to prove whether or not it's a parallelogram. So for example, if you're looking at a parallelogram, the first thing you're going to want to do is check the slopes of the sides. So you're going to want to compare this side to this side to see if in fact both of the slopes are in this case 0. And then you're going to want to look at this slope and this slope to see that they're also congruent to each other. Then you're going to check the distance of opposite sides, make sure they're congruent, and check your diagonals. Okay? And so this kind of will give you the steps. Once you've determined by looking at a picture what shape you think you're looking at, then you can follow these steps to actually make the proof. So let's do some of these on our own. Okay, and you have this on the back of your homework. So the first thing I'm going to do is I'm going to look at this and I'm going to say, okay, I know I'm looking at a quadrilateral. So I'm thinking it's going to be a 4-sided figure. And these are my points. And I want to know what is the most specific name that I can give this quadrilateral. And I need to prove it. Okay, so the first thing I'm going to do is draw a picture. I'm going to go over 1 and up 5. Call that W. Call this X. Here's Y. And here we go with Z. Okay, and I'm going to connect the dots. And when I see this picture, I'm thinking this is either going to be a square or it's going to be a rhombus. So I'm going to follow the steps for a square. Okay, and the first thing I'm going to do is I'm going to check to see that my diagonals are congruent. So I'm going to look for diagonals are congruent. And so to do that, I'm thinking congruent diagonals, I'm going to have to use the distance formula. So I'm going to first calculate the distance from W to Y. Okay, so I'm going to redraw this in green. And I do this by, I'm going to go up and over. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1. And so I'm going to do 1 squared plus 9 squared, because that's my triangle that I'm making. That's got a 9 and that's a 1, equals, and when I work this out, I'm going to get c squared. And so this is 1 plus 81, which equals the square root of 82. And the square root of 82 equals 9.06. So I can say that that side is 9.06. Now I'm going to check the second diagonal, which is xz. And that's here. And I see that to go here, I'm going to go down 1 and over this many. So that's 1, 2, 3, 9. And just knowing that I'm using the same numbers, I know that 1 squared plus 9 squared is going to equal the square root of 82, which is 9.06. So check. The two diagonals are congruent in length. So the last thing I want to do is check to make sure that these diagonals are also perpendicular. Okay? And so if they're also perpendicular, then I can prove that it's a square. And so how do I prove that it's a square? Well, I first look at the slope of WY. Okay? And the slope is rise over run, so I went up 9 and over 1. So the slope is positive 9 over 1. Now I'm going to look at the slope from Z, from X to Z. And I notice I went down 1 over 9. And so since these are opposite reciprocal slopes, I can say these lines are perpendicular. And so how do I know this is a square? Because the diagonals are both congruent and perpendicular to each other. If this were a rhombus, like I also initially thought, then my two diagonals would not be congruent. They would be perpendicular, but they would not be congruent. So I can do that to prove that it's a square. Any questions? Please raise your hand and feel free to ask. Let's look at a second one, and again, I'm going to do it the same way as I did the first one. So the first thing I'm going to do is graph my points. And it's important to label them as well, because you have to answer questions about these points. Over 1. Here we go, there's x. Over 4. Down 1, and that is y. Over 1, down 5. And that is z. So I'm going to connect my dots. And what do I see here? Well, it appears to me that I'm looking at a trapezoid. And the reason it appears like a trapezoid to me is that these sides definitely look parallel to each other, but the other two do not. So I'm going to go through and I'm going to see if I have a trapezoid on my hands. And the first thing I'm going to do is I'm going to look at the slope. So I'm going to look at the slope of all four sides to make sure that I've got two slopes that are in common. So first I'll look at Wx, and here I'm going to rise 2 and run 4. So my slope is 2 over 4, which is equal to 1/2. Okay. I'm going to look at the next. I'm going to look at xy. And when I do that, I see that my slope is going to drop and go over. So I dropped 1, 2, 3, 4, 5, 6, and I went over 3. So my slope is -6 over 3. Okay, the next side I'm going to look at is here. This is, let's see, I went up and over. So I went up 1, 2, 3, 4, and over 1, 2, 3. So from z to y is 4/3. And then lastly, I'm going to look from y to z. And so I'm going to go down and over. And I go down 8, 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2, 3, 4. So from w to z is -8 over 4. So it looks like I don't have any parallel lines really, but then I look a little closer and I see that 8 over 4 is actually -2, and 6 over 3 is actually -2. And so because I have just these two sides that have the same exact slope, I know that I'm looking at one set of parallel sides, so it's going to be a trapezoid. Now the next thing I can do is I can look a little closer and see, now are my legs, the sides that are not parallel to each other, are they congruent? And when I look, I know they're not going to be congruent, because this one is this one has 2 squared plus 4 squared, and that's not going to be the same as 4 squared plus 3 squared. This one's going to be much larger than the other one. So I'm just looking at a basic trapezoid. Okay. I'm going to do one more example with you, and then you'll have an opportunity to try some on your own. So the third one, if you'd like to see how well you're doing with this, you might want to actually, let's do this. Go ahead and pause the video and see what you can do on your own, and then come back and I'll explain the answer. You're going to notice that this shape was a kite. So the first thing you want to test is to make sure that all the slopes are different. And even though the numbers are the same, or these might look like they're opposite reciprocal, they're not. All of the slopes are different, and therefore we're looking at a kite. Secondly, you want to make sure that the sides are, consecutive sides are congruent. And so that's what we've done here. These two sides are consecutive, they are congruent, and these two sides are consecutive, they are also congruent. And therefore, we have a situation where we have a kite. And that's all you got to do to prove it. So go ahead and try some practice problems on